Hello everyone, welcome back to another discussion in dynamics. Today we will continue talking about kinematics of rigid bodies, but our subtopic, our new topic is velocity analysis. The content of today's discussion is brief lecture review and then two examples. So without further ado, let's dive straight into our discussion. When it comes to brief lecture review, I prepared something before recording this video. So I would like to focus on velocity analysis between 2 points, let's say A and B, that belong to one rigid body. So let's assume that we have a rigid body and that rigid body has angular velocity omega body. Let's specify 2 points that belong to this rigid body, point A and point B, and the vector RBA is connecting them. So if we would like to express velocity at point B with respect to velocity at point A, we should go for this expression. So VB is equal to VA plus omega body times RB with respect to A. We will use this expression approximately like 5 times today. Okay, so that's that when it comes to lecture review. Now let's solve example number 1. Feel free to pause the video and familiarize yourself with the problem statement before we start our solution. All right, so what do we have in here? We have 2 bodies, yeah? Actually, we have 3 bodies, yeah? So we have cylinder A here, we have cylinder B, and we have also connecting bar CD that connects cylinder A with cylinder B. What do we know? We know radii of 2 cylinders. We know that our bar CD has omega CD counterclockwise. We know that there is no slip between 2 cylinders. And we also know that this guy is fixed. This guy is fixed. And what do they ask us to find? They ask us to find omega of this body. So we can already assume it. Let's assume that it is rotating in a positive direction, okay? So it will be this direction. This is omega cylinder B, and this is unknown. And they also ask us to find velocity of this point. By the way, I usually assume if I don't know what is the angular velocity of certain body, I usually assume that it rotates in a positive fashion, so counterclockwise. Okay, so our solution is following. Let's find omega cylinder B. In order to do so, let's express velocity of point D, so this point, in 2 different ways. Let's express velocity D in 2 different ways. What do I mean by that? I mean that we should do velocity analysis between D and E, or D and E and D and C. Okay, so in here I can just write VD is equal to VC plus omega CD times R DC. I used in here omega CD, so omega of this rotating bar, because points C and D belong to that bar. Now let's write down expression for this velocity analysis. So in here I will just write velocity D is equal to velocity E times omega of certain body times R dE. It's only 6 minutes of our discussion, but I would like to ask you to pause the video and think what subscript I should put here. Omega of which body I should put in this equation. Feel free to pause the video right now and try to figure out omega of which body is here. Okay, so for those of you who got it right, congratulations. And for those of you who just came here to put together notes, the answer is it's omega of cylinder B. Why? Because points D and E, points D and E, they belong to this cylinder. All right, so let's solve this expression right now. So our VD is equal to VC actually, okay, let's copy this one. So I believe that this vector is zero vector. Why? Because point C is fixed. So we can express our VD in the following way. Omega CD is 0, 0, 5 positive, because omega CD rotates in a positive fashion. So this would be 5. And now this vector. What is this vector? R DC. Let me scroll up the board. RDC is this vector, this green vector. So I think that its components will be following. At this configuration, it will be RA plus RB, 0, 0. Okay, let's also find this vector, RDE. So our RDE will be here. It's connecting point E and point D. So RDE will be RB 0, 0. Okay, let's plug in our vector here. And by the way, how much was RA, it was 0.1 and RB was 0.3. Aha, so their sum will be 0.4. Okay, let's write our determinant. I, J, K, 0, 0, 5, 0.4, 0, 0. And this is equal to 0 here, this is 2, and this is 0 meters per second. Great. Now let's look at this expression. I believe that VE is also 0. VE is also 0. And maybe you can also pause the video right now if you would like to and think what is the reason that VE is 0? That reason is obviously no sleep condition. Oh no, that no, yes, no sleep condition, yes. Sorry for that confusion. Okay, since we assume that omega sil b is positive, we can just write 0, 0 omega sil b times, how much was RDE? It was 0.300. Let's use our determinant. 0, 0 omega sil b 0.300. And answer to this is 0.3 omega sil b 0. Great. So we found omega d VD. We expressed VD in two different ways, and naturally VD has to be equal to VD. Yes, this is tautology, this is trivial. So from here we know that this vector has to be equal to this vector. But we care only about the y components, right? This expression. So right now we can write that 2 is equal to 0.3 omega sil b. That means that omega cylinder b is equal to 20 divided by 3. Grab your calculator and obtain. Actually, I didn't grab my calculator. I just left it like that. It's 20 divided by 3 radians per second. And I think that our assumption was correct, yes, because we ended up with a positive value here. Omega sil b is a positive value. That means that what we assumed at the very beginning was correct. So that means that our omega sil b vector-wise is 20 divided by 3 k radians per second. Counterclockwise. And I think that this is answer to part A. Yes. So we found this. Okay, so now part B. Find VF. So I would like to copy this drawing here. And I think that the fastest way to find VF is to run velocity analysis. Yeah, but not so fast. Maybe you can pause the video and think of which of these points I should choose so that calculating VF is very fast. Velocity, in other words, velocity analyzes between which 2 points we should run to finish the problem immediately. Take a couple of seconds or pause the video and take as much time as you want. All right, so if you got it right, congratulations. And if you just come here to put your notes together, the correct answer is velocity analysis between points F and E. So I would like to write velocity F is equal to velocity E plus omega cylinder B, because these 2 points belong to the cylinder, times RFE. Okay, and the choice of these 2 points is the fastest, is the best, because we already know what is velocity of point E. It's 0, for the same reason as before. And now we have to find this vector. So what is VF is equal to 0, 0, 20 divided by 3, I hope you remember, times this vector, this green vector. So this will be RB 0. However, we know what RB is. Yes, it's 0.3. 0.3 and 0.3. Okay, let's do our determinant right now. I, J, K, 0, 0, 20 divided by 3, 0.3, 0.3, and 0. Okay, so this will be equal to following value. This times this. So this will be just -2. Then this times this. This will be 2. This is 0. This is 0. And this is 0. Great. So we found velocity of point F. This is our answer to part B. Answer B. Let's draw our velocity in this drawing. I think it will be pointing this way. Yes, this is our velocity of point F. Please observe that this angle is 90 degrees. Okay, this is the end of example number 1. So now let's do example number 2. feel free to pause the video and familiarize yourself with the problem statement before we start our solution. Okay, so what do we have in here? We have our piston system, right? And I draw equivalent drawing here. This is equivalent drawing. So we have point A that is fixed. We have first piece of our piston system that has length L1, it's rod AB. We have also rod BD that has length L2, and we have our body D here. What do we know? Aha, we know what is the length of L1 and L2. We know that this theta is 40 degrees. And we also know that body AB has clockwise velocity, omega AB, which was 2000 RPMs, but I just converted it to radians per second. Please also observe that if we would like to express this value vector-wise, we should put minus in front of 209.4395. Why we should put minus here? Because they told us in the problem statement that this omega is clockwise, so it rotates in a negative fashion. And they ask us to find VD. I hope that most of you see that VD will have only one component. VD is equal to VD 0, 0. How do we know that? Because this is the trajectory of our piston. Yes, our piston can only move back and forth. It cannot have every other component of its velocity has to be 0. Okay, so that's our first information. Solution. So before we find velocity D, let's maybe figure out what is velocity B. So I would like to, in order to find it, I would like to run velocity analysis between points B and A. So I can write VB is equal to VA times omega AB. Oh, excuse me. Here plus, not times. Plus in here. Times RBA. Okay. So I think that this velocity is 0 because A is fixed. Omega AB they gave us, it is 00209.4395 negative. And this vector I will draw in the picture. RBA will be this green vector. This one. This is RBA. So I hope that you see its components. RBA will have following components. L1 cosine theta, L1 sine theta, and 0. Okay, let's do our determinant. 0, 0, minus 209.4395 I, j, k, L1 cosine theta, L1 sine theta, and 0. I will just align everything so it looks good. Okay, let's solve our determinant. The determinant is equal to 209.4395 L1 sine theta negative 209.4395 L1 cosine theta, and the third one should be 0. Let's just double check it. Yes, it has to be 0. It has to be 0 because this is a planar motion. Okay, plug in values. I believe that L1 was 3 inches and theta was 40 degrees. So if you plug in values and if you grab your calculators, you will obtain that our VD is equal to approximately VB is equal to approximately 403.8753 and minus 481.3199 and 0 inches per second. Okay, we found VB. This is our VB. Now let's find VD. Now we are able to find VD. And in order to do so, I would like to run, probably it's not going to be surprising for you. I would like to run velocity analysis between point D and B. So I have to write VD is equal to VB plus omega of certain body times R dB. And that certain body, that subscript, will be, of course, BD, omega BD. It will be omega of this rod, Why? Because points B and D belong to that rod. Okay, let's assume this omega BD. Let's assume that it rotates in a positive fashion. So it will be rotating this way. So this is omega BD. So we will have VD that is unknown. Actually, it is kind of known because we know that it is VD00, right? This guy we just found. So let me just copy it from here. We assume that omega BD rotates in a positive fashion. So I will write 00 omega BD. And now we need this vector. Let me copy this drawing. Here. Okay, we need RDB. That vector will be red. So, and that vector is here. This is RDB. Aha. So in order to find its components, we have to introduce new angle, this angle. This angle will be called psi. Okay, I can show it to you here. This angle is called psi. So I believe that the components of our vector RDB will be following. L2 cosine psi and minus L2 sine psi 0. This is actually not psi, this is theta. Sorry, or okay, we can call it psi, just for the purpose of this video. So now let's find this determinant. ijk is equal to the second row is equal to 0, 0 omega bd, and in here we will have L2 cosine of this angle, whatever its name is. In here we will have minus L2 sine of so-called psi, and 0 in here. Okay, let's find that value, the value of this determinant. I'm going to write it here. So it will be L2 omega bd sine of this angle, L2 omega bd cosine of this angle, and 0. Yes, it has to be 0. Okay, so now we can copy this. So now we can write this expression here. So we have Vd 0, 0, and this is equal to this vector, plus this vector. Right? Let me look into my notes just to make sure that I didn't make any mistake. It seems that I made one mistake. Let me double check. No, everything is fine. Yes, everything looks fine. So, how many unknowns do we have in these equations? We have this is not known. This is not known, and our angle is also not known. So I hope that you can see, guys, that we have two equations in here. We have equations in the x components, and one equation in the y components. We can even write them down, because Vd will be equal to this, and 0 will be equal to this. So we can clearly see that we have two equations and three unknowns. 3, because this is also an unknown. However, it can be this can be fixed because we can actually figure out what psi is. Let's find psi. We can do it based on this triangle. I will show you in a second. Let me copy this drawing, and I will eliminate some stuff from here. We don't need that. We don't need that. We don't need this. We don't need that. We don't need that. Oops. Okay. So we can figure out what psi is based on this dependency. Let's define this length. This is h. Okay, and now based on this green triangle, we can see that sine theta is equal to h divided by L1. Okay, so that means that our h is L1 sine theta. Now, based on this red triangle, we can clearly see that our sine psi is h divided by L2. So that means that h is equal to L2 sine psi. And we also know that h has to be equal to h. Yes? So that means that L1 sine theta is equal to L2 sine psi. So that means that our psi is equal to invert sine L1 divided by L2 sine theta. Let's plug in values. Psi is equal to arc sine of 3 divided by 8 sine 40 degrees. Grab your calculators and obtain that psi is equal to approximately 13.9482 degrees. Great. So all of a sudden we don't have two unknowns, two equations and three unknowns, but all of a sudden we have two equations and two unknowns because this guy is known. Okay. So we have two equations and two unknowns. And the unknowns are VD and omega BD. Okay, so feel free to solve this system of equations. So after some algebraic transformations, you should end up with omega BD equal to approximately minus 61.9929 radians per second. So that means that our assumption was incorrect, yes? Omega BD will be rotating our rod BD in a clockwise direction. And we assumed counterclockwise. So this will be clockwise. But this is not what they are asking us for. Yes, this is just a side product. This is just a side product of our solution, because they actually ask us to find VD. Yes, and VD, if you solve that system of two equations, you should obtain that it is equal to 523.4197 inches per second. So that means that it's a positive value. So that means that VD will be going this way. In the I direction, inches per second. So it is going this direction. Okay, and this is the answer. And this is the end of our discussion. So I hope you enjoyed it. I hope I explained everything clearly. And in case you have questions, please write them on Piazza. Please visit us during our office hours, or feel free to leave a comment below this video. Thank you for your attention, and I hope to see you on Wednesday, this time in class. Have a nice weekend. Bye.